Imagine a world on the brink of annihilation. Volcanoes darken the skies with ash, spewing toxic gases into the atmosphere. The oceans, once teeming with life, transform into stagnant, acidic pools. Forests wither and die, leaving behind vast wastelands. This is not science fiction, it is a chilling chapter from Earth's history, the Permian-Triassic Extinction event, also known as the Great Dying. Around 252 million years ago, life on Earth faced its greatest challenge, a cataclysm so severe that it nearly extinguished all life on our planet. The Great Dying was the most severe of the 5 major mass extinction events recognized by scientists. While the extinction event that killed the dinosaurs is more famous, the Permian extinction was far more devastating. It obliterated an estimated 76% of all marine species, and a staggering 95% of life on land. From the depths of the oceans to the highest mountain peaks, the planet was ravaged, pushing life to the very edge of existence. The story of the Great Dying is a stark reminder of the power of nature and the fragility of life. The main culprit behind this global catastrophe lies buried beneath the frozen expanse of Siberia. It is here we find the Siberian Traps, a vast region marked by ancient volcanic activity. These were not ordinary eruptions, they were among the largest volcanic events in Earth's history. For hundreds of thousands of years, these volcanoes unleashed a torrent of molten rock and toxic gases, forever changing the planet's fate. Imagine, if you will, an area the size of the continental United States, covered in lava flows that stretched thousands of feet thick. These eruptions were not explosive fire fountains like Mount Vesuvius or Mount St. Helens. Instead, they oozed out of fissures in the Earth's crust, creating vast lava plains. These eruptions were continuous, lasting for tens of thousands of years at a time, with only brief pauses between them. The Siberian Traps eruptions were not just notable for their scale, but also for the sheer volume of gases they released into the atmosphere. Carbon dioxide, methane, sulfur dioxide, these greenhouse gases, trapped for millennia beneath the Earth's surface, were suddenly unleashed in colossal quantities. These gases would prove to be a deadly cocktail for life on Earth. The massive influx of greenhouse gases into the atmosphere had a devastating impact on the Earth's climate. Carbon dioxide, a potent heat-trapping gas, began to accumulate in the atmosphere, preventing heat from escaping into space. This caused a runaway greenhouse effect, leading to a rapid and dramatic rise in global temperatures. Scientists estimate that global temperatures rose by as much as 10 degrees Celsius, or 18 degrees Fahrenheit during this period. To put that into perspective, that's about 5 times greater than the warming we've experienced since the Industrial Revolution. This rapid warming had catastrophic consequences for life on Earth, both on land and in the oceans. The intense heat scorched the land, turning once lush forests into arid deserts. Wildfires raged across continents, releasing even more carbon dioxide into the atmosphere. The oceans, too, felt the heat. Warm water holds less dissolved oxygen than cold water, making it difficult for marine life to breathe. This warming, coupled with other environmental stresses, would have devastating consequences for marine ecosystems. As temperatures soared and the oceans absorbed more and more carbon dioxide from the atmosphere, a sinister transformation began to take place beneath the waves. The oceans, once teeming with life, were slowly being starved of oxygen. This process, known as ocean anoxia, would prove to be one of the deadliest consequences of the Great Dying. Ocean anoxia occurs when the oxygen levels in the water column drop to dangerously low levels. This can happen for several reasons, but in the case of the Permian extinction, it was primarily driven by the massive influx of nutrients into the oceans. These nutrients, released from volcanic ash and the weathering of rocks on land, acted like fertilizer, triggering massive algal blooms. While algae produce oxygen through photosynthesis, they also consume oxygen when they die and decompose. The massive algal blooms during the Permian led to a surge in decomposition, which consumed vast amounts of oxygen from the water column. This created vast dead zones in the oceans where oxygen levels were too low to support most marine life. Section 5. Death from below, hydrogen sulfide and the stench of extinction. As if ocean anoxia wasn't bad enough, the Permian extinction had another deadly surprise in store for life in the oceans. In the oxygen-depleted depths, a new threat was emerging: hydrogen sulfide. This toxic gas, produced by certain types of bacteria, is lethal to most marine animals. Hydrogen sulfide is a colorless, flammable gas with a characteristic rotten egg odor. It is highly toxic, even in small concentrations. In the oxygen-starved oceans of the Permian, hydrogen sulfide began to build up, poisoning the water column and killing marine life on a massive scale. Evidence for the widespread presence of hydrogen sulfide during the Permian extinction comes from geological formations known as black shales. These dark, layered rocks are rich in organic matter and often contain high concentrations of pyrite, a mineral that forms in the presence of hydrogen sulfide. The widespread distribution of black shales from the Permian period suggests that hydrogen sulfide poisoning was a major factor in the marine extinction. Section 6. Landfall, the collapse of terrestrial ecosystems. The Permian extinction was not just a marine event, it also had a devastating impact on life on land. The same environmental stresses that were suffocating the oceans, global warming, ocean acidification, and toxic gas releases, were also wreaking havoc on terrestrial ecosystems. As temperatures soared, once lush forests withered and died, replaced by vast deserts and scrublands. Wildfires raged across continents, releasing even more carbon dioxide into the atmosphere and further exacerbating the greenhouse effect. The loss of plant life had a cascading effect on terrestrial ecosystems, leading to the collapse of food chains and the extinction of countless animal species. The fossil record paints a grim picture of the devastation. Large, herbivorous reptiles, unable to adapt to the changing climate and the loss of their food sources, were among the first to disappear. They were followed by the predators that depended on them for survival. By the end of the Permian, an estimated 95% of all land species had vanished. Section 7. The long road to recovery, life in the aftermath. In the aftermath of the Great Dying, the Earth was a shadow of its former self. The oceans were eerily silent, devoid of the vibrant life that had existed for millions of years. The land was a desolate wasteland littered with the remains of extinct plants and animals. Life had been pushed to the brink, but it had not been extinguished entirely. Recovery from the Great Dying was a long and arduous process. It took millions of years for ecosystems to begin to recover from the devastation. The first organisms to reappear were simple, opportunistic species such as bacteria and algae that were able to tolerate the harsh conditions. Gradually over time, more complex life forms began to evolve and diversify. In the oceans, new species of fish, mollusks, and corals emerged, slowly rebuilding the marine food web. On land, reptiles began to diversify, filling the ecological niches left vacant by the extinction of their predecessors. Section 8. The Dawn of the Dinosaurs. A new world emerges. The Permian extinction marked a turning point in the history of life on Earth. It created a blank slate, allowing new forms of life to evolve and flourish. Among the survivors were a group of reptiles known as archosaurs, which would eventually give rise to the dinosaurs. The Triassic period, which followed the Permian, was a time of significant evolutionary innovation. The archosaurs, with their advanced features such as a more upright posture and a faster metabolism, were well suited to the warm, dry climate of the Triassic. They rapidly diversified, evolving into a wide range of forms, including the first dinosaurs. The dinosaurs, however, were not the only animals to thrive in the Triassic. Other reptilian groups, such as the pterosaurs, flying reptiles, and the ichthyosaurs, marine reptiles, also evolved and diversified during this time. The Triassic was a time of experimentation and innovation as life recovered from the brink of extinction. Section 9. Conclusion. Lessons from the Great Dying. The Great Dying stands as a stark reminder of the power of nature and the fragility of life. It shows us that even the most diverse and resilient ecosystems are vulnerable to catastrophic events. The Permian extinction was a global tragedy, wiping out the vast majority of life on Earth. However, the Great Dying also offers a message of hope. Life, though severely tested, ultimately endured. From the ashes of the extinction, new forms of life emerged, more diverse and resilient than their predecessors. The dinosaurs, those iconic creatures that have captured our imaginations for generations, owe their existence to the Great Dying. The lessons of the Permian extinction are as relevant today as they were 252 million years ago. We are currently living through what scientists are calling the sixth mass extinction, driven by human activities such as habitat destruction, climate change, and pollution. The rate of species extinction today is estimated to be 1,000 times higher than the natural background rate. The future of life on Earth, including our own, depends on our ability to learn from the past. We must take action to mitigate the impacts of human activities on the environment and prevent another great dying. The fate of life on Earth is in our hands.